Hey there, y'all. Today we're going to look at 4.2 on solving quadratics by using square roots. In this section, you're going to be able to solve quadratics by using square roots. That's the name of the lesson. And we're continuing in our standards that we've looked at in section 1, FIF4 being able to interpret the key features, and FIF8 being able to translate between equivalent but different forms. And so the first thing we need to talk about when we talk about solving by square roots is to remind ourselves what is a square root and what does it do. And so when we think about the square root of 9, well, the square root of 9 is equal to 3, and we've known that for a little while. And the reverse of that 3 squared is equal to 9, right? And so we know that one undoes the other. And so the inverse, or to undo the squaring of a number, is to take its square root. And so as we look at taking the square root of x, we've got to understand what it actually means, what we're taking the square root of. Because not only does 3 squared give me 9, but something else gives me 9 when it's squared. Negative 3 squared does. Because negative 3 times negative 3 gives us positive 3. And so we see that in this case. And so when we look at the examples, we're going to see that we're not going to only get the positive answer, but we're also going to get the negative answer to these radicals. And so let's look at some of these examples as we go through. And so in example 1, we see x squared is equal to 16. And so when we think about solving equations, we're always undoing operations, right? If we see subtraction, we'll undo it with addition. If we see division, we undo it with multiplication. The same happens when we see exponents. We undo a square by taking the square root of both sides. And so I'm going to take the square root of x squared and the square root of 16. But when I take the square root of something that was squared, I have to account for both the positive and the negative answer that comes out of it. And so we use this positive or negative sign, or plus or minus, you might also hear it called. And so on the left side, the square root and the square cancel out, leaving just the x. On the right side, we have that plus or minus sign, or positive or negative, and the square root of 16 is 4. And so we end up with not one answer, but 2. We end up with our 2 answers being negative 4 and positive 4. And so when we think about these answers, we've got to know that we're getting 2 answers. And both these work, right? Because if I plug in 4 squared is 16. But if I plug in negative 4 squared, negative 4 times negative 4 is positive 16. So we're getting both solutions that work. And so let's talk about the steps when it comes to solving for quadratics. So step 1 is to solve for the squared item. So in this case, we just had x squared. But we might have, let's say, 3x squared. Or we might have x squared minus 5. And we want to be able to solve and get that square term by itself. Step 2, take the square root of both sides. And don't forget your plus or minus sign. And then step 3, if necessary, if there was something else still there after we took the square root of both sides, and it's not just the variable, we need to solve for the variable. And so when we think about our order of operations and we think about PEMDAS, remember that we work backwards when the direction is to solve. So we'll get rid of any addition subtraction first, then multiplication and division, and then we're getting rid of that square that is the exponent. All right, so let's go ahead and look at some more examples in example 1 to see this in action. In example B here, we have 3x squared is equal to 75. So we're going to divide first both sides by 3. The 3's over here will cancel, leaving the x squared equal to 25. We can then take the square root of both sides. And remember that when we take the square root of something that was squared, the other side needs to account for both signs, positive and negative. And so the square root cancels the square, leaving just the x. And x is equal to positive or negative 5. And so our 2 solutions are negative 5 and positive 5. And if we plug both those in, we would see that both work. 5 squared is 25, times by 3, we get 75. Same thing with the negative 5. The square cancels the negative, we get 25 as well, times by 3. Let's look at example C. m squared minus 12 is equal to 5. So in this case, we need to first add 12 to both sides. And remember, we're solving an equation, so whatever we do to one side, we have to do to the other. And so m squared is equal to 17. We can then take the square root of both sides. Don't forget your plus or minus. So m is equal to positive or negative square root of 17. Well, is there a square root of 17 that's nice and comes out for us? No, because square root of 16 is 4, but square root of 17 is just going to be a decimal. And so we can go to our calculator and get that decimal. M is going to be approximately equal to, pay attention to the wavy equal sign, that means approximately equal to, means we've rounded it, positive or negative 4.12. If you go on your calculator, it's 4.12, so on and so forth. We're going to round to the nearest hundredths for most of these answers when we need to. Now, pay attention to directions. If it tells you to round to a particular decimal place, round to it. If it doesn't tell you to round, then leave it as the square root of 17, positive and negative square root of 17. And so when we write the answer here, it would be negative square root of 17 and square root of 17. If we do go with the decimal answer, it would be the negative 4.12 and the positive 4.12. And we would, again, deal with both answers. And again, with the rounded answer, if we were to plug it back in, it's not going to work out perfectly because we have truncated this number a little bit. We've cut off some of the decimal places. It doesn't come out exactly equal to 5. It's 4.9 something. It's going to be very, very close because we've rounded to so many places. And so, again, that's what we'll pay attention to when we do those. All right, let's go ahead and look at example D. In example D, we've got a squared plus 20 is equal to 0. So our first step here, again, we're trying to solve for that variable. So we're going to subtract 20 from both sides. And so a squared is equal to negative 20. We then need to take the square root of both sides. So square root, don't forget your plus or minus. Square root canceling the square. A is equal to positive or negative square root of negative 20. Well, let's go to our calculator and we type in the square root of negative 20. And when we do that, we get an error. Well, the error is that there's nothing that we can multiply by itself to give us negative 20. Think about like when we try to do the X puzzle, right? We're trying to multiply to negative 20, but we're trying to have both of these numbers be negative because that's what a square root is. I have to have a negative number and a negative number. Well, a negative times a negative is a positive. And so what we get is that there is no real solution. Now, when we go on to Algebra 2, we're going to talk about complex solutions, and we'll deal with those solutions there. But for now, we're looking for real solutions, and the real solution is that there isn't one. There is not a value for A that will multiply by itself to give us negative 20, because it's just not possible. All right, let's go ahead and look at example E. So in this example, we see x plus 5 squared, all that in parentheses squared, is equal to 36. Well, the x plus 5 is inside a parenthesis, and when we think about the order of operations, we're working our way up the order of operations. This is inside a parenthesis, so I can't touch it until I get past the exponent. And so our first step in this case is to take the square root of both sides. Square root canceling the square, we're left with x plus 5 is equal to positive or negative 6, because we took the square root of 36. And so now we got to finish solving for x, which means I need to subtract the 5. And so I'm going to minus 5 and minus 5. And so x is equal to positive or negative 6 minus 5. And so to get our two answers, we're going to deal with both the positive 6 and the negative 6. And so we're going to write this out as two answers. 6 minus 5 is equal to our x, or x is equal to negative 6 minus 5. Well, 6 minus 5 is 1. Negative 6 minus 5 is negative 11. And so our two answers are negative 11 or positive 1. So again, when we see it like this, we've got to pay attention to our order of operations as we solve each piece. All right, so let's look at example F. In example F, we've got 4 times 2x minus 1 squared is equal to 16. So first off, we've got to get anything that's not inside the parentheses away. And so our first step here is that we're going to divide both sides by 4. And so we'll divide there, giving us parentheses 2x minus 1 squared is equal to 4. And so now we've got the parenthesis by itself with this power, and so we can take the square root of both sides. And so we'll take the square root and the square root. Don't forget your plus or minus. Square root cancels the square, leaving 2x minus 1 is equal to positive or negative square root of 4 is 2. And so now we're able to solve this like any other equation. And so we're going to add 1 to both sides. And so at this point, we really need to work this as two separate problems. And so we're going to have 2x is equal to positive 2 plus 1, or 2x is equal to negative 2 plus 1. Over here, we're going to get that 2x is equal to 3. Here, we're going to get that 2x is equal to negative 1. So again, we see how we're working two separate problems now. And so our last step on both these problems is to divide by the 2. And so the x will cancel. X is equal to 3 halves, or x is equal to negative 1 half. And so that's our two solutions, negative 1 half and negative 3 halves. So again, using our order of operations, we will cancel out addition and subtraction first, then multiplication or division, then that exponent. Remember, undoing that exponent by taking the square root. And then if there's anything inside a parenthesis, we'll deal with that after we've taken the square root. And remember, we want to split this into two problems so we can deal with the positive side of this answer and the negative side of this answer. Now, one thing to note is that it will not always be a negative answer and a positive answer, because sometimes we'll add something in or we'll divide something by a negative or something, and signs are going to change on us. And so we got to pay attention to what those two answers are going to do, and they're not always going to be one positive, one negative. It could be two positives or it could be two negatives. All right, so we're going to look at a couple of word problems next, and we'll look at those and look at the steps on how to solve each of those. So let's take a look. So in example 2 here, we're going to look at Fenway Park is the home of the Boston Red Sox. The park offers seats on the top of the left field wall, the green monster for any baseball fans. A person sitting in one of these seats accidentally drops his sunglasses on the field. The height, h, of the sunglasses can be modeled by the function h is equal to negative 16t squared plus 38, where t is the time in seconds since the sunglasses were dropped. And of course, h is the height we said at the start of the sentence. Find the time it takes for the sunglasses to reach the field. Round your answer to the nearest hundredth of a second. And so, again, we're dealing with one of these problems like from section 1, where when it hits the ground, what's the height above the ground? Well, our h is going to be 0 in this case. So 0 is equal to negative 16t squared plus 38. And solving this for t, we're just going to take our steps to undo everything, right? So our first step is that we're going to divide everything by the negative. Well, we can't divide by negative 16 in this case, but we can divide by negative 2. And so dividing everything by negative 2, we get 0 is equal to 8t squared minus 19. Then we can add the 19 to both sides. So plus 19 and plus 19. And so 19 is equal to 8t squared. And then finally, or not finally, but our next step is that we can divide by the 8. And so we get 19 over 8 is equal to t squared. And so now we could take the square root of both sides. And so we'll take the square root of both sides. Don't forget your plus or minus. T is equal to positive or negative the square root of 19 over 8. Now, 19 over 8, that's not a nice number. We're going to have to go to our calculator and get the square root of it. So let's go ahead and do that. So in your calculator, you're going to type in, we want to have the square root. Remember, that's going to be second and square root. It's going to open a parenthesis as well. 19 divided by 8, close your parenthesis. And when we hit equal, we get a nice crazy decimal. 1.54110, so on, right? And so t is approximately equal to positive or negative 1.54, rounding to the nearest hundredth. But remember that we're dropping something on the ground here, so we can't have it hit the ground before we release it. And so the negative answer does not make sense here. And so our final answer here is the sunglasses take 1.54 seconds to hit the field. And so this is our final word answer here. And so in a problem like this, again, we're going to plug in for h what height we're going to. And again, if we're going to the ground, if we're going to the water, our height above that is 0 at that point. And so that's the height that we're going to. So in example B, we have a plane is flying at an altitude of 500 feet when it releases a care package with a parachute. The package's altitude can be modeled by h is equal to negative 2t squared plus 500, where t is the time in seconds and h is the altitude of the package. Find how long it takes for the package to reach the ground. Round your answer to the nearest hundredth of a second. And so we see that our form is a little different here because we're not just a falling object, we've got a parachute, so that's slowing down our descent. And so we'll still do the same steps to solve this equation. And so we're looking for this when it hits the ground. And so what we're going to do, 0 is equal to negative 2t squared plus the 500. And so solving this one, we can divide everything first by the negative 2 to get rid of the common factor. And so 0 is equal to t squared minus 250. And so we can add the 250 across. So plus 250 and plus 250. So we get that t squared is equal to 250. We can then take the square root of both sides. Square root, don't forget your plus or minus. And so we're going to take t is equal to positive or negative square root of 250. And when we take that square root of 250 in our calculator, so square root of 250, we get 15.81. And so 15.81. Again, we're dealing with an item that is being dropped. Our time cannot be negative, so we're going to ignore the negative answer. And our only answer is that the package takes 15.81 seconds to land. And so again, just make sure that you are paying attention to what we're plugging in to these problems. So that's it for today. I hope you'll have a good one, and I'll catch y'all next time.